Okay, so this one we want to use the resistance of conductors formula, and you'll notice that we have centimeters and we have ohms, and so metric units then, where our base unit is meters, right? And so let's think about that. Now we're asked for the length, and so I'm going to start off by saying that resistance is equal to rho times length divided by cross-sectional area. And so if we solve that for L, we have resistance times the cross-sectional area divided by rho. Rho comes from the table, and the resistance is given. Of course, we got to find the area. Okay, so the area then is pi. We're given, yeah. Okay, so pi times d squared over 4 for the area. And we have pi. Now, let's write d here in as meters, right? So d is equal to 0.127 centimeters multiplied by 1 meter over 100 centimeters. And so 0.00127 meters, or 1.27 millimeters. And I don't know if it's necessary to point that out, but 1.27 times 10 to the negative 3 meters is probably the best way to write it, right? So when we put that in here now, pi times 1.27 times 10 to the negative 3 meters squared. And so our idea is that we want base unit to get our decimal in the right spot. Okay, so area is equal to. Now, we're putting this in the calculator. 1.27 exponent negative 3. And we want to square that, multiply by pi, and divide by 4. And if we do that, I got 1.2, I'm going to call that 7, I guess, times 10 to the negative 6. And now my unit is meters squared. Okay, so now that goes back now to my formula for resistance that I have solved for length. My resistance is 1.7 ohms, and my area now, and I've got a bunch of numbers in my calculator and I'm going to leave in there, is actually 1.266768, and so it rounds to 1.27 times 10 to the negative 6 meters squared. And now rho, I have to pull that out of the table of properties of common conducting materials, which you can find in your PowerPoint presentation, or because the slides for that is posted, right? Or from the table in your workbook on page 73, and it's manganin, right? And so we have then for manganese, rho is equal to 48.0 times 10 to the negative 8 ohms times meters. And so, important to pick out the one with the metric unit, of course, because the meters has to cancel. Okay, so I suppose I should have just wrote it in here, eh? 48.0 times 10 to the negative 8 ohms times meters. Now, that's a decimal there, right? So, when we're looking at this example now, remember that ohms here cancels with ohms here. Meters here cancels with one of the meters in the numerator, and the unit we're left with is meters. And it's important, to make sure that the units are correct. Okay, so the length then is our area that we got still in our calculator multiplied by 1.7 and divided by rho, 48 exponent negative 8. And when we do that calculation, I came up with 4.4, and I want to round it up 9. And our unit again is meters.